So we're going to continue talking about rates in E.2 and talk about unit rates. So, the earlier example on this page was representing rates in a variety of ways. What became useful for us to compare was to make unit rates. So you did this without really knowing that's what you were doing. Also, it's fine to express you make $136 in 8 hours, but that's not how you talk about your rate of pay. Oftentimes, unit rates are the easiest way to compare things. And so that's what we're going to talk about. Off the top, we have a little bit of trivia. I had to look this one up. I didn't know this terminology. A denominate number is just a number with a unit of measure attached. So I left some room because I think examples here make a whole lot more sense. So 5 kilometers. 1 hour are two examples of denominate numbers. That's all they mean. Nothing to do with fractions or denominators, right? They're just a number with a unit of measure attached. So a rate, we've already talked about this, is a comparison of two denominate numbers with different units of measure. So as the example here, that's 5 kilometers per hour. A unit rate, and this is the one that we do intuitively, is simplified so that it's rate per 1 unit. So it's 1 hour in there, or it's 1 gram of food or whatever, or 1 package of Annie's or whatever it is, right? Mixed numbers and decimals are preferred when finding a unit rate. The cool thing about this is that calculators are possible, right? And so the classic example of unit rates is at the grocery store. So you may have noticed this in the grocery store. If you want to decide which, box of breakfast cereal or granola is cheapest, hopefully the grocery store you go to has unit rates listed. On the Moodle site, I actually put a recent article and a little bit of an audio podcasty thing about the value to the consumer of having unit rates posted at the grocery store, because it definitely saves you money when you can compare, on equal footing, like we did with the pizza making earlier on the page here. So here's some examples of rates. So if you go 12 feet in 16 seconds, you could reduce it, or you could do the math on that. So it's 3/4 feet per second, or in all honesty, what we'd probably do is say it's 0.75 feet per second. Same here, 20 miles in 10 with 10 gallons of gas maybe. We would represent that as 20 miles per gallon. I like using the slash here for reasons that we'll keep talking about in this unit, but that's how we say it, is per, when we're talking about the rates, which you probably already knew. So these ones express as a unit rate, and sometimes there are options on how to express that rate, which I've already alluded to, but it is in your homework in this section. So if I were to do the calculator or work with these ones, I'd get 25 miles per hour, or in stateside they'd write 25 mpr, or that's an H, right? Are all the same thing. If you make, oh, this is be nice, $180,000 in 2 years, that's not how people usually say what their salary is, right? You could do the math, and that's $90,000 per 1 year or per year. And much like we've done in algebra, if it's 1, you don't write that in there. This one's a bit of a funny one. I did the calculator work on it, and 2 divided by 14,000 gives me an awkward number, 0.00142, right? And that would be years per dollar. Well, that's not as useful. It's absolutely accurate. There's nothing wrong with it. We would often, because there are options in how to represent these, it'd probably be $7,000 per year, right? That seems a little bit more useful. Both are totally right? There's nothing wrong with either one of them, but this one's just a little awkward. And so you have options, and there are multiple ways of getting these things right. Okay, so let's move on and practice some of these. So pitcher had 320 strikeouts in 280 innings. So if we want to figure out strikeout per inning rate, we do 320 strikeouts. I forgot the E in there. Divided by 280 innings. I tried to give us direction. If you have to round an answer, I've tried to give us direction on this. It says round to 3 decimals in this section, or in this question. That would be 1.143 strikeouts per inning. Another sports one, so sports stats often get recorded as rates like this. So 702 points in 31 games. So find out her points per game. So good old calculator, we're going to round to the nearest tenth. So that would be 1 decimal place. That would be 22.6 on my calculator points. Whoop, not points. Sorry, got my letters backwards. Points per game. So, these are all well and good to really get an idea of how things are going, but really comparing rates is where unit pricing really has its strength. So player A scored 50 points in 9 games, and player B scored, oh my goodness, 260 points in a whole lot more games, in 36 games. So from these stats, it says which player scores at a higher rate. So if I do the math, I've got 5.6 points per game. And doing the math on this one, I get 7.2 points per game. So this allows me to compare, and it allows me to say that player B has the higher rate of scoring. Another sports one here. If we compare which one scores at a higher rate, we've got Hassan and we've got Lee. So 25 goals in 8 games. And Lee is 52 goals, in 18 games. So grab your calculator, calculate these rates. I get, what is it? 3.125 goals per game, or 2.8 repeating goals per game. So you don't have to report out on what their rate is, but we just want to know which one is scoring at a higher rate. And that answer would be that Hassan. Scores at a higher rate. All right, so enough with the sports stats. The next ones are unit pricing. And so these are rates. This is most useful in the grocery store. And again, check out that link to the recent article. I got pretty excited when I realized that, our course had this in it, and saw that article a few weeks ago. So in this one, when you're doing pricing, you typically round to the nearest cent because that's useful. Sometimes if something's really inexpensive, it might be to the nearest tenth of a cent, but typically, like with money, it's dollars and cents. So we've got brie costing $11.53 for 8 ounces. So how much per ounce? So we'd have 11.53 in 8 ounces. So if we want to figure out the unit price of this, we just do the math on it. It's 1.44125 per ounce, or in practical terms, $1.44 per ounce. 20 pounds of potatoes for $3.98. You always put the money on the top in unit pricing and the other denominant number down below, right? Both units on these, I can use my calculator to figure out what it says. So 0.199, which really is 20 cents a pound. So I'd write 20 cents per pound. You could also write it as, 20 cents per pound. Same thing. The idea with these, we're rounding to the nearest cent. Okay, one more, or two more here. Give these ones a shot. I'm going to write the answer out for us. You can show your work. This might be something that you've done before. Those are your answers here. This one has some tricky rounding. You actually get 0.9996, which rounds to $1 per pound. Okay, so comparing these, we're using this idea of unit pricing to figure out which is the better deal, right? So we've got a few of these ones to try. There's more in your homework. Just one of these in the notes here. So milk comes in two different size containers, a gallon and a quart. Oftentimes bigger is cheaper, but that's not always the case, which is why looking at unit pricing can actually save you money, especially if there's sales on a smaller sized container. So we're going to talk about the gallon and we're going to talk about the quart containers. And we're going to figure out the unit price for each and to figure which is the better buy. And so the gallon would be a price per ounce, and it's 128 ounces, it tells us. And that would calculate out to 0.0382 or about 3.8 cents per ounce. This is a case where it's so small that putting a decimal in there, even though you don't have tenths of a cent, you can compare a little bit easier. So a quart would be $1.29, and that's 32 ounces. On my calculator, it works out to 0.0403. So if you'd rounded this one to 4 cents, you might have lost track that 3.8 cents is actually better than 4 cents an ounce. So this would be 4 cents per ounce. And so all of this is really just to compare which is the better buy. This one is cheaper.